Don't be like my mom. Have 2 sets of music. She had to get 8.
Oh no, I only have 2. I have
She has a full set.
Right? Yes.
She had 2 sets.
I'm
not opposite. I only have 2.
So she had a full
So
set.
I feel it.
For now.
In high school, and then like when she was like 26.
Okay. So, proportions. So this is again, every problem you get basically from here to the end of the year, you're deciding 2 things, means and proportions, and then population or sample. So you're always looking up at this. Well, this won't be here the whole time, but you're thinking about this. And so for means, this is like a population, so this might be like SAT scores. And you've got like a whole range of SAT scores. There's people that got 400, there's people that get 1600, there's 1,000 in the middle. So you get this giant range. And then when you start taking a sample, that's when we got those boxes falling down, and we get this smaller distribution here. Well, for proportions, it's a little different. If I said like, what percent of students here drive to school? Let's say, what is that, like half maybe? No, just like in this 40%. It's probably like most of the juniors and seniors, but not all. So let's say 40%. Well, if I say what percent of students here drive to school and you say 40%, that's not a distribution, right? It's not like SAT scores. It's not like there's a bunch of them and I plot this. If you tell me that like what percent of people drive to school here is 40%, it's a dot. It's literally one number. So that's why there's no standard deviation. It's just like a straight up number. But this still happens. So I can then take, well, let's say I take a sample of 30 kids and find what percentage of them drive to school. That'll be a box that drops down. I'll take another 30, which is probably a different number, right? And that'll be another box that drops down. And you start taking samples of 30, and you still get this sampling distribution down here. But up here, there's not a distribution. It's just like a straight up number. So understand that, hopefully, first of all. So I can't really even ask you, like, let's say this was 40%. I can't even ask you 5 questions about the population. Okay, what percent of students drive to school? 40%. Well, what's the probability that 60% or more drive to school? Like, it doesn't make any sense because it's just, you already know you know what I mean? You already know the number. So there won't be any questions about this. All the questions will be about the sample. So, if I look through, what tends to confuse people is that even though so you're splitting into, am I working with means or proportions? But then even once I'm in proportions, that sampling distribution has a mean. Like the middle of the proportions is still called the mean. So if I read through this, 65% of your students here prefer block scheduling. The mean of that sampling distribution is 0.65. Everything's got to be in proportions, which is just like a percent that's a decimal. 0.65, 0.12, 0.07. The standard deviation of it is, that's the one I wrote up there incorrectly before. The square root of 0.65 times the complement, that's like the P and the Q, divided by 1,000. So I get, in this case, I get 0.015 for that. And then I can ask you the probability questions. Once you know the mean and the standard deviation, I know it's approximately normal, then I'm just using normal CDF. So that part forward is the same. Do you guys see where I'm getting these 2 numbers from? So for part C, I'm going to say normal CDF. 70% or more, so I'm going to go 0.7 and up. So 0.7 to 99999. What is the mean? I know we're working with proportions, but that little sampling distribution still has a mean. The mean of that is 0.65. You can call that, in this case, P or P hat. Why can you call it either one? Because they're the same. And then here you're putting the 0.015, and that's the square root of PQ over N. Sorry, I'm like writing all over my typed part. And then you type it. actually never really even find that decimal. I would just go to this spot and type what's the square root of 0.65 times 0.35 divided by 1,000. Make the calculator do all the work. Did you guys get 0.147? You didn't get 0.147? Oh, I need parentheses when I put it into that spot. So if you're going to do it the way I just showed you, don't. You got to do 0.65 times 0.35 and then divided by 1,000 and kind of like different parentheses. Alright, so 0.000458, which is basically 0. That's what you got, right? You didn't get this? Oh, you got it here? This one? Yeah, okay, that's fine. Yeah, that's fine. That's like a rounding issue. No, it's my fault this time, not yours. Yeah, it's like, right. That's the difference between like 0 and 0, basically. Alright, 10% of students at Pioneer feel like the school is a caring community. As students taught at Pioneer, it is a freaking madhouse. There's like, I think there's like 5,000, 8,000 students there or something. Nobody knows anybody. Like, you're in a room with people and like, they're not your friends. Some of them maybe, but the school's so big. It's like a college. It was crazy.
You go into the school, there's just like so many random like halls that
My neighbor teaches there. She says she doesn't even know all this now.
I believe it.
Is there still that many since that Skyline?
It's what?
Is there still that many kids on the Skyline school?
Oh, probably less.
but there's still a lot. There's still a lot.
Okay, anyway. So, when I was writing this question, I feel like my teachers kind of know you and like care about you a little bit. But at Pioneer, I was like, these people don't even know each other. Like, that was just weird. I randomly select 200 of them. What's the probability? Blah, blah, blah. Shh. So are we dealing with means or proportions? Proportions. As soon as I see percentages, that's how I know I'm dealing with proportions. What is the mean of the sampling distribution? Closer. 0.10. So you gotta take the percent of the population that is true, like that cares, that thinks it's a caring school or has a car or whatever, and turn it into a decimal. The standard deviation, so then you take that 0.1, multiply by 0.9, divide by the sample size. What's the sample size in this one? 200, and then square root all of that.
It would be 3,000. It would be 3,000. Divided by 3,000. And
No, it would be 200. I randomly select 200 of them.
Then wouldn't the first one be 75?
Then you divide it by
We did the first one.
So we did the first one wrong.
Oh no. My brain hurts.
I know. I'm sorry. I didn't even see the 75 in the first one. You do the sample size. Crap, I'm sorry. Can we just pretend number one never happened?
Yes.
I'm fixing it right now. I should cross it
I
out.
don't have an eraser.
Just scribble.
I know. That's why
So the n is the size of the sample.
It's a rough one, maybe.
It is. I don't know why, but it is. The n is your sample size, not your population size. I apologize for that. That makes sense, right? It's like the size that you take that matters, not the size of the giant. Like there could be 8 billion people at Pioneer. If I only take 200, that's what I'm looking at is those 200. My bad. So less than 8%, so I'm at a negative 9999, comma 0.08. The mean is 0.10, and the standard deviation is that 0.0212. So I get 0.1727. Is it the same thing? So I'm sorry about that, but to be clear again, it's the sample size, like the size of the sample that you take. So it's the smaller of the two ends that you're going to use. So if I look at number 3, like A and B are there to kind of guide you, but they usually won't ask you that part. They usually just jump to like, hey, what's the probability? You got to know to put those in. So 10,000 people in Milan, 70% of them are pro-union. I randomly choose 90 people. So I know that my P is 0.7, my N is 90. So B is just the probability, but like expressed in decimal form. N is your sample size. And then I'm going to go normal CDF. So 60% or less, so negative 9999, comma 0.6. So don't put 6, everything you put in here should be a decimal. We're proportions here, so if you like, a lot of people will put 60 instead of 0.6, and that will obviously give you a very different answer. So make sure you're putting decimals here. And then the mean is 0.7, and the standard deviation is the square root of 0.7 times 0.3 over 9. I get 0.0192. So I'm on So if you're getting that, great. Do number 4. If you're not, let me know so I can hopefully fix here. Yeah. Square root, and then it's second. Like the previous answer in that spot. So that's your standard deviation. Try that. If it doesn't work, let me know.
Should I put that whole thing in, or
Just like the first, round it where it makes sense, Riley. The more you put, the less likely it is that you'll screw it up, you know? Yeah. So P is 0.15, N is 60, and then I want to know between 10 and 20%. So normal CDF. Am I going to put 10 and 20 here, or 0.1 and 0.2? 0.1 and 0.2. And then the mean is 0.15, which is P, and then the standard deviation is the square root of 0.15 times 0.85 over 60. So did you get 0.723? 0.7229. Alright? So that's it. That's the whole. I'm not saying it's easy because you're still kind of like, well, wait, you're still kind of figuring out what means proportions are and like when to use which. But there's two things in the whole chapter. And it's working with means, knowing whether you're going to put this guy or this guy, and then working with proportions where you're basically always putting those guys. So I wanted to leave you some time to start your con because I figure some questions will come up like when you start it. So I'd like you to start your con now so I can come around and help people as issues come up. You'll also have tomorrow to work on your con because I won't be here. And then Wednesday we'll do like a review of all the stuff. Micah, what's up? You gonna come over?